the Data Science Channel. This is the unit of Monday, December 19th, 2022. To tell us this, we're going to start off with a little bit of fun with Fortran, okay, and has to do with the video I saw on Stand Up Math. More details in 15 minutes, but sit back, relax, back with you folks in right around 15 minutes, okay? Okay. As always, welcome back to the Caribou Data Science channel on YouTube. So we're going to begin with hopefully a little Fortran. Uh, you using the chat GPT AI client. First we have to go back and actually find the original video I was talking about. Because it doesn't appear to be this one here. And these are all in orders. We're looking for a video on a particular conjecture. If you part of my French. Not the ABC conjecture. But let's come up here. Let's search for this is exactly what we're looking for right here. The 3n plus 4 conjecture, but we're looking. So the great Collett's conjecture, okay? So let's, first of all, let's do a quick search, get a brief explanation of exactly what this conjecture actually is. Okay?
Hey teachers, I've got a great project I want to tell you all about, and you and your students can get involved with it. So this is just a quick video, by the way, on the second channel. I'm at home in my study, should be writing my book, but that's not been announced yet, so you did not hear that from me. Anyway, I set up a organization called Think Maths. And the idea behind this is it would make free resources for schools, as well as sending people into schools to run like workshops and talks and do sessions, both of which are now done by Zoe Griffiths, who was a maths teacher, and now she works with me at Think Maths. And Zoe had the idea of doing a big collaborative COLATS super map that your students
Okay. Collett's conjecture is one of the most famous unsolved problems in mathematics. Conjecture asks whether repeating two simple uh, arithmetic operations will eventually transform every positive integer into one. It concerns a sequence of integers in which each term is obtained and the previous terms follow. If the previous term is even, the next term is one half of the previous term. If the previous term is odd, the next term is 3 times the previous term plus 1. Okay? Let's come over now and see if we can actually find a video that explains how this actually works.
Easy Wheels started as my college project, and we now sell our wheel covers all around the world.
All right, welcome to today's Math Minute, a very special Math Minute number 50. We've made it. Started at the bottom, now we're at the top. I wanted to do something special for Math Minute number 50, and so I have for you an investment opportunity. This is not Bitcoin, this is not cryptocurrency, not a Ponzi scheme or anything like that. Instead, here's my offer for you. I'm going to flip a coin, and if that coin comes up heads, I'm going to take whatever amount of money you're investing with me and I'm going to cut it in half. Hold on. You haven't heard the other half of the investment. You don't know what else is going to happen.
Watch this.
Dass ein jeder Numerus par einer Summe duorum primorum sei, halte ich für ein ganz gewisses Theorem, ungeachtet ich dasselbe nicht demonstrieren kann. That means that a given number is the sum of two primes. I hold it for a completely certain result, looking aside from the fact that I can't myself prove it.
What do you think this is?
Let me have a look. Right.
Like maybe seaweed or...
It definitely looks like something from the sea, like a...
Okay, well, it's interesting mathematical seaweed, and I'm going to explain exactly how we made that image, because to me, that image is one of the most mind-blowing pictures, illustrations of very simple maths ideas. So it is, and we're going to get there, the Collatz conjecture.
I'm trying to find the one I actually watched.
I'll do a follow-on video a couple months from now once we're all done, and I'll show off the amazing super map. I'm pretty excited. We have some rules, of course.
To really get math and science?
You gotta do it.
3n plus 1.
That's why learning on Brilliant.
Jeff Ligarius, a mathematician I admire a lot, thinks it's one of the hardest problems around. Erdős actually said, this is a problem for which mathematics is perhaps not ready. Turns out all this fuss is about a problem that any fourth grader can understand. To show you how this all works, I'm going to give you an example. Brady, choose a number between 1 and 10.
I shall go for 7.
All right, let's start with 7. Now, I'm going to apply two rules depending on what number I get to. I'm going to do this in succession. And if n is even, then I'm going to take n and divide it by 2. If n is odd, then I'm going to take n, can't divide it by 2 and get a whole number, so I'm going to take n and multiply it by 3 and add 1. Those are my rules. And I'm interested in what happens to n. Does it grow to infinity? Does it get small? Let's see what happens with 7. 7 seems to be an odd number, so I multiply by 3 and add 1. 3 times 7 is 21. Check me on this. And add 1 is 22. I go to 22. 22 is certainly even, so I'll divide by 2 and get 11. 11 is odd, so I multiply by 3, getting 33, and add 1, get 34. 34 is even. I divide by 2, and I get 17. So far it's sort of going up and down. But 34 was the biggest yet, so maybe it's headed off to infinity after all. 17. So 17 is odd. I multiply by 3. 3 times 10 is 30. 3 times 7 is 21. 51 plus 1 is 52. Even. Divide by 2 and get 26. Still even. Divide by 2 again and get 13. Now it's odd. Multiply by 3 and add 1. 40. 40 is even. I divide, I get 20. I divide again, I get 10. I divide again, I get 5. Boy, we fell down a long way. Maybe we're heading for a small number after all. Multiply by 3 and add 1, I get 16. Whoa, 16, very even number. I get 8 I get 4, I get 2, and I get 1. If I do it again, something interesting happens. I go 3 times 1 plus 1 is 4. Whoops, I'm back to 4. But now I'm just going to cycle forever, going through 1 over and over again. So I got to 1. 7 got to 1. Now, people have tried lots of numbers beginning this way, and so far, all of them have gone to 1. They've tried roughly 2 to the 60th numbers. That's almost 10 to the 20th. So the famous Collat's conjecture says that every number, every whole number will eventually get to 1. And a huge amount of work has been done on this problem by combinatorics.
Now, the obvious
by
question is,
number
why
theory.
is this conjecture?
This is the problem.
What is
maybe
the
mathematics
practical
is not
application
ready
of a
for,
conjecture like that?
but that any fourth grader could
So,
play with. And
there you have it. So our task is to write a Fortran program to calculate the Collat's conjecture. So all here is just go ahead, open up code. Oh, that's a different project from another time. Let's see. Let's see. Open up folder. Let's see, documents, Fortran. Do we have something actually here? Okay. We're going to say the reason it's not probably because it's not actually probably because it's got a space in it. Okay. So our challenge is to try and write, try to write, see if we can get the chat GTP to write a Fortran program for us to calculate the Collat's conjecture. Okay. Now we understand the rules. Sounds good. Fortran Collat's conjecture. Of course, it's easy for the chat to say this is a simple example, but we'll see. So let's just come back up here. The Collat's conjecture is a mathematical conjecture that states that for any positive integer, if you repeat the following sequence, if n is even, divide by 2, if n is odd, multiply by 3, and add 1, then you will eventually reach the number 1. no matter what value you start with. The process is known as the codex sequence, with a starting value n. For example, if we start with number 6, the codex sequence would be 6, 3, 10, 5, 16, 8, 4, 2, 1. Here's a simple Fortran program that generates the codex sequence for a given value. Okay, let's copy the code, paste it over here. Okay, that is a fairly simple code, isn't it? To be perfectly honest. So now, this program prompts the user to enter a positive integer, then generates a codex sequence for the number by repeatedly applying the steps described above. It counts the number of steps taken to reach 1 and prints the result. Okay, let's just run this first, see what happens. Enter, okay, let's say 9. Interesting, okay. So what we can do is, we could open up a terminal. We could say, what the heck is A? You know what the problem is? I think we have an extra space. We have an extra space between the okay. Let's try this. Problem is, it's in the same. It's in the same. Okay, this is interesting, but it doesn't actually print out the individual numbers, right? Let's do this. The 7 took even more than 10. So kind of an interesting program. Uh, it actually does work, which is always helpful. Let's try 21. Interesting, huh? Let's try 22. Right, so he starts at 22. 22 is even, so you divide by 2, you get 11. Then you multiply by 3 to be 33 and add 1, which is 34. Okay, makes perfectly good sense, doesn't it? uh, fun with Fortran, right? So the Elon Musk and the Twitter saga continues. You may have saw this. He he posted on Twitter. He posted a a poll, and he said, "Well, the question was, should I step down as a head of Twitter?" Okay, and he says he will abide by the results of the poll. Well, the results so far have 57% say he should step down, and the other part says he shouldn't step down. As bizarre as it sounds, that a CEO would leave his professional fate to a random thing, there's a reason to think that Musk will actually abide by the results. He restored former President Trump's account after this choice when it was in a poll, and he reinstated banned journalist accounts this weekend when users voted in favor of that opinion. But even in posting a survey in the first place, Musk seems to be issuing a cry for help. In roughly several weeks since he reluctantly bought Twitter for $44 billion, the only constant has been chaos from the debacle of a rollout of Twitter subscription service Okay. Truly, uh, okay. So that concludes our Fortran lesson for tonight. Okay. So let's close this. Let's come back over here. Let's open up a different folder. Uh, I should get rid of most of these. You know that? That really is the main thing. Stallion. Python simplified. I think Python simplified may have just posted a new video very shortly. Going to be posting a new video. Let's open this folder here. Open our file. Now what this is part of was a video on YouTube. Obviously, here's the link. It had to do with data cleaning. Okay. Now just doing a couple uh, really quick plots. A histogram here by age. Most of the people who took this survey were within somewhere between 50 and 60. You can see we got outliers going backwards and forwards. Okay. Then we came over here, changed the name of the changed the one name. Up to this point, also you didn't really do anything at this point. Okay, nothing tricky up here. You noted real pandas, numpy, seaborn. Read the file, pulled out the data types. Okay. Most of the types are floats. There's an object, which is gender, and there's a class, which is an object also. Let's look at the shape, the size of the data. Today is 1,009 records and 14 columns. Here's a list of all the columns. We want to change this one here to read patient number, okay? Then later on, as you'll see, we'll actually come down and we'll look at this one here and this one here as part of the data, okay? Well, that's nice. I can actually open up a file from here. Okay, good. And here's the original directory, or the original video. All right. Shape, column names, describe the column names. This gives us some statistical analysis, very standard. You count mean, standard deviation, minimum. These two here are kind of interesting because if you take the 75% and subtract the 25%, you get what's called the interquartile range, or IQR, okay? Now, these are IDs, so this really isn't really numbers. We should probably actually read it. How can you have this? We really should do a change type on this, probably, and convert it to a factor, maybe. Change age. Why is age all capitalized and the rest of it aren't? That's not kind of strange. But again, you get the maximum, you get the count, you get the minimum. Then we did a quick. Then we did a very quick histogram plot of the age groups. Okay, and also we did a very quick plot of the or box plot of the age group also. We could of course, and actually the author does this. Okay. Okay. So now we're going to change this to this and look at the columns again. Okay. This just says make the changes to the underlying data frame, okay? Now you can see the patient's number, all right? Check for missing values. There are a few missing values in here. That's where we pick up the story. Back over to history. Truey is from Holland, and she's mainly a game streamer. Uh, so we're looking over here for this thing again. Data clean Python. Let's go ahead and
What is a model? I think you can ask a million people and you get a million different.
so we'll just walk our way through this video.
Hello and welcome to another video. In this video, we shall be looking at data cleaning using Python. So, first of all, needed for.
So I'm going to try to skip ahead.
And I run.
What we're looking for, okay? And what we're looking for here is how to fix the null values for some of these things here, okay? So he changes this, okay, but then he goes back and he removes the duplicates for the other ones, okay? And there is a function. There's a function that's called duplicates or drop duplicates. Okay, let's just see if I'm right about there. Drop duplicates. We're not going to do that. But first we want to fix the number 3. Okay. So let's see, check the number of columns. Rename columns. Looking for nulls. Let's pick it up here.
You cannot neglect it. You cannot just drop it because it is going to really affect the data set. But when it is low, you can you can drop it. So because this 3 is quite on the high side, we are going to replace it. So in replacing it, have to replace the missing values in the column H B A 1C. Now in replacing it, we're going to look for the mean value. We're going to use the mean value to replace it. So mean value is equal df square bracket. Okay, and then I simply drag this.
Okay. If you not know what this data is, this is actually data that has to do with things like HbA1c is a measure for cholesterol. So this all has to do with heart disease and cholesterol and various things like that. HDL, LDL, those are the 2 forms of good and bad cholesterol. BMI is probably body mass index. TG, I'm not sure what TG is. Gender is fairly obvious. I mean, now we could ask a question up here. Let's just put one more. Let's just do a quick. Uh, I mean, a histogram is only going to return two things. Only going to return two values. So we're going to say this count plot. Gender, I think is what it is, right? Let's see if this works. Let's just say okay, so here we go. So now we got the count by. Oh, you see a problem right here. This, uh, yeah, that's one of those things we probably have to change. Oh boy. Okay, we'll get to that in just a moment. He actually covers this further down the thing. Okay. But you can see there's still a lot more males than females who took this. Okay. I knew I should have left that alone. But let's come on down there then.
Triple out the mean. So I run this.
Come up here and say, so the average is 8.284155.069, so forth. Okay. Now, I actually watched the video there earlier this afternoon just to get the feel for it, but that's quite all right.
Okay, so I want to check what is the mean value. So I write it out. What is the mean value of this particular column? And when I run this, okay, so you can see that the mean value is 8.284. Now we want to use the mean value to actually fill it up. So we say df, or instead of writing, we'll simply, okay, let me comment this using the mean value. Yes. Missing records. Now, using it to replace the missing record, I will simply highlight this, drag and drop here, and then I will use the dots fill now method. And then I say missing value. You fill it up with the missing value.
Oh, okay.
In place again. Equal true.
Okay, so it's simply going to be now. Fill NA. Fill NA. Mean value in place. Okay. So we come back up here and we run this a second time. Okay. Tell us whether or not we got rid of the number or not. And now the 3 is gone. So what do we do with the rest? Well, with the rest of these things, we can actually come back up here. Remove. Okay. Then all we do is just a drop NA, right?
Okay, and I run. Okay, so we want to confirm. Sorry, please. I want to confirm the change. Confirm. As a data analyst, anytime you are working on a data set, you always try to confirm the change so that you don't work in the dark. Now df dot is null. Okay, dot sum. Then okay, so let's quickly see this. We can discover that the HBAIC has actually been filled with the mean value. So there it is no longer containing a missing value again. Now since that has been settled, so for the rest of this, I would want to drop them down. So I'll simply comment this.
Okay. Drop NA is a code, should be fairly simple. Equals drop NA. And then verify.
Dropping the missing value. Now to do that, I'll say df1. So I'll now give you this a new data frame. It's called df dot drop now. So you use the drop now method to drop NA values. And then in dropping it, I want to check I want to confirm again.
Okay, what I'm doing is I'm just going to overwrite the existing table. Okay, rather than creating a new, I'm going to override the existing table. Let's see what happens here. Now I can see there's no more NA values. Okay. We dropped an A, we confirmed the missing values.
That it has been dropped. Here dot small dot sum. And then I run this. Okay, so we can see that it has successfully been run. Yes, so there are no missing values again. So the next thing we want to do is we want to check for duplicate values. Now, before we go to that, I actually noticed something in the data set. Before we go to that, let's check for the information. Let's check for information concerning the data set. Information concerning the data set. So we use here as info. Okay, and then I run this. And then you can see that there are, okay, DF1 please. DF1 because it has been changed. I run this. Okay. So we can see that there are 999 values that are not null in nature. That means they don't contain missing values.
Let's just try something here. DF. Let's see. Gender, not gender. What are we looking for over here? Class. Uppercase. There's that. Let's do a value counts. So here's the trouble. Why do we have these two N's and two Y's? Well, you can't actually see it here. Okay. Can we say head here? No, we can't actually see it here. Okay, we can't actually see it here. But I'm going to give you a little hint. Things you can always look for. Misspelled, upper and lowercase. I mean, we saw in the gender, we saw capital M, capital F, and a lowercase f. Okay. All right. The other thing we could also look for is well is white spaces. Either x y either either white spaces in between two words or white spaces before or after the words. Like I said, I watched the videos and we're going to tell you the problem is some of the Y's and some of the N's and some of the Y's have extra spaces after them. Okay. And my question is, well, it's just, so is that what you're coming up to next?
And then the first two columns are integers, and then the third one, which is the gender, is an object, while the rest are
Class is
floating
an object.
data type, floating numbers, and then the class is also an object. Now I want to take a look at the class. I want to take a look at the class. Now to take a look at the class, I want to check what are the type of classes of people that we have, in this data set. Now to do that,
So that's what it is now. Now it's to basically the point here. Okay, but let's do this. Let's first of all, let's problem with, all right. So we come over here. So what you can see is yes and no are the big ones, but you also see you got an extra no here, right? So what's the difference? Well, the difference is, yes, is that there's a space after these two here. So that tells us we have to fix something, okay? And I hate to say, but what the seaborn plots really are incredibly helpful for exploratory data analysis because it's so easy to use. All right. So our question then becomes is this. Let's do a chat. Let's see. So how can we, there we go. Now, okay, now here's the, now here's the thing. What he does is, he goes in and he uses a replace function, I believe, and then he replaces so he replaces the n space with an n. But it'll be very easy. Okay, we can use this also. We can use this to fix the. Let's use it. Let's use this to replace the two. ID. Okay. Come down here, and we say, okay. Now we're going to change F with F. And what was there up here? I thought I plotted gender up here someplace. And then we're going to say M from now let's do a quick plot. Count plot. This is a temporary plot. There we go. So we fixed that problem. Good. And verified and verified. Now we're going to get tricky. Now we're going to get tricky. Now we're going to take a look. Now we're going to fix this problem up here, okay? We're going to use the trim function. Okay, the trim function to get rid of white spaces. So let's come back up here. Now we got it. And in my opinion, that was a much easier solution than going in and actually typing, typing say P dash space and you're replacing P dash space with P. We just stripped all the columns. I mean, we could actually do this. And to a certain extent, this wouldn't be a bad function to start out with, just to make sure all your columns, okay, all your columns have no white spaces in them. Okay, so there. So let's see where we are now. The questions we're answering are fairly simple Python questions, but nonetheless, the ability to just look up a possible solution, that's huge. That's huge. Let's move on.
I'll say df1 dot group by, and then I use, to do that I'll say df1, so I'll now give you this a new data frame. It's called df dot drop now. So you use the drop now method to drop NA values, and then in dropping it I want to confirm again that it has been dropped. df.sum and then I run this. Okay, so we can see that it has successfully been run. Yes, so there are no missing values again. So the next thing we want to do is we want to check for duplicate values. Now, before we go to that, I actually noticed something in the data set. Before we go to that, let's check for the information. Let's check for information concerning the data set. Information. df.info. Okay, and then I run this, and then you can see that there are df1, please, df1, because it has been changed. I run this. Okay. So we can see that there are 999 values that are not null in nature. That means they don't contain missing values. And then the first two columns are integers, and then the third one, which is the gender, is an object, while the rest are floating data type, floating numbers, and then the class is also an object. Now I want to take a look at the class. Now to take a look at the class, I want to check what are the type of classes of people that we have, in this data set. Now to do that, I'll say df1 dot group by, and then I use group. Then I put the class. Okay. Then this SS. Then I want to find out the aggregates. Like counting them.
You're looking for here now.
Okay, so these are the classes that we have in the column class. So we
Now, he could, of course, done a simple value count, right? Okay.
have class N, which is 102.
And even a quicker plot, just to visualize that information.
Number, and then we have another class N again, which is 1, and then we have P, which is 53 in number, Y, which is 832 in number, and then Y again, which is 9 in number. So you can see that there's a problem with this column, because how can Y here and then also Y here? So what is the difference between the both of them? Now, in order to know that, I will now use the function. I will say I want to check for the unique values in the column class. So to check for that, I'll say df square bracket class, and then dot unique. I'll call in the unique method when I run this. Okay, so we can see a very
I only got 3 because I already cleaned it, right? Okay, good. But if you actually did this the first place, so if you have here, you would see there's a space after the N and a space after the Y. Okay.
good. So this is the N, and then this is another N, and then this is P.
So we use the strip command to strip away the extra white spaces rather than actually going in and changing the actual values themselves.
And then, so if you look at this data properly, you will notice that there is a space in between this place. Yes, there is a space in this N. Meanwhile, there is no space here, and then there is a space in this Y, and there's no space here. So that is actually a problem also, because we cannot be working with a class. Let's say we want to visualize this particular column class. We cannot just have NNPYY against the measure. It does not tell well of the data. So this also require cleaning. So this require cleaning. Okay, so to clean that, we want to replace it. To clean the column, I replace. So I will replace this unique variable to be this, and then I also replace this one to become this. So I replace the unique values. Now, in replacing the unique values, I will say df1, and then you pass in the class column. Is equal df1 square brackets class column dot string dot replace. Sorry, please. So then we want to change y with a space. We want to change it to y without the space, and then we'll do the same thing for n. But in doing the same thing for n, I simply copy this, Ctrl C, and then I paste it here, Ctrl V. Then I come here, put n, and then I put n. So when I run this, okay, so we can see that it has successfully run. Now what is happening here is that I call out the class column in the df1, and then I said df1, I want to replace the unique values with the unique values having y with spaces inside. I want to replace them with the unique value of y without the space. Now what .str means is that .str casts the column class. It turns the column class to a string data type. So it is from the string data type before we can now perform the replace. So a column must the dot replace method only works when the column is in a string data type. Now remember, let's go back to the info. I want to check the info. Now if you look at the class here, you will discover that the class is having the object the data type is object. So you cannot replace it directly. You have to first of all cast the column to become a string before you can now replace it. So that is what is happening there. Now we want to confirm if the change has happened. So to confirm the change, I simply say df1 square brackets class dot unique, and then I run this. Okay, so you can see that it has successfully been changed. So there are 3 unique values in this particular column. Now we move over to the next point, which we are supposed to. It is to check for check for duplicate values, and then we are also checking for outliers. So we are checking for duplicate values. Now, before we go to check for duplicate values, let me check for outliers. Now, what are outliers? Outliers are values that are exaggerated. Let's take, for example, you have a column having records like, and having numerical records like 2, 4, 5, 6. Many of them are mostly 1-digit numbers, and then you now have that same column a record like 1,000. So you can see that 1,000 as a record in that particular column is an outlier. So sometimes outlier comes in as a kind of a mistake during data collection. So when you are dealing with data or you are cleaning data, one of the top priority is to look for outliers, because outliers can especially if you are building a model from your data, it can actually distort the model and actually report a false it can produce a false result. So we want to check for outliers in the data. So I simply comment this, checking for outliers in the data sets. Now to check for outliers in the data set, I want to use the box plot. Yes, the box plot. And the box plot is actually a visualization chart that is available in the Seaborn visualization library. So the xns.boxplot, and then I want to call out the CR, specifically the CR. Now I want to take us up a little. Now when you come to this 5th row,
Okay, so there's our box plot.
and 5th column,
We're getting close to the end now.
you see that it is CR. Now CR is a floating number. So outliers can only happen in a float number. So you can go through each and every one of them, using the box plot, So that is how you can check for outliers. Now we want to run this. Okay, so you can see here that there is a very huge gap from this point to this point. So this particular record is an outlier in terms of when you compare it with these ones. So we want to deal with it. So how do we deal with it? I want to use the maximum quantile of the column. Yes, the record of the column that falls within the highest.
Okay, but generally, I think anything beyond the whiskers here is considered to be an outlier. That's a different matter.
Yes, the fourth quartile. Yes, the fourth quartile. So we want to take that and then we'll say um, choose the maximum quantile to fill in the outliers.
Hey, by the way, if you are watching from the background, thanks so much for stopping by, taking time off your day or evening. Although I'd appreciate it if you would maybe stop by the chat session and just say hi. Also, be sure to click that subscribe button and click the bell next to the subscribe button to be notified whenever Caribou Data Science goes live again, okay? I will say that my general stream schedule is Monday through Thursday, 8 p.m. Eastern Time. That's for you folks outside the U.S., that's New York time, okay?
Now, I want to say max CR is equal df1 square bracket CR dot quantile open bracket 0.995. So we are using.
Okay, now we're going to calculate the quantile value. All right, there we go. So as he says, so I'll be back in one moment. I need to go to visit the little boy's room here. This is- So we're going to say so anything beyond 401, according to him, is going to be an outlier. Although I really think that this anything beyond the whiskers, from what I remember, from my non-statistical point of view of just watching videos here and there, the whiskers mark the bounds. Okay, the whiskers mark the bounds. So anything beyond this whisker are all considered to be outliers. But the important thing is we shouldn't just randomly delete outliers. We have to make sure we understand what this outlier actually is. Okay, which is an interesting question, and find out exactly where this should be. Now we could also do a histogram of this value. And what we would see is we would see a distribution which is skewed to the right. Okay. Nonetheless, let's just come down here and see exactly what he says now.
At least they will print the max. See, I want to know the maximum quantile using this particular value 0.9.
Right. So is I think you have to. I'm trying to thinking how to add a title. I wonder if you can actually come back over here and simply add a title, like a main or a title function back in there. Let's just come over here. Chat. I mean, this really is. Okay. Okay, that's fine. We'll leave it for now.
995. Now when we run this, okay, so we can see here that 401.0. So the maximum quantile for the column CR is 401. Now we will now use this number to fill up the outlier, which is 800. So we create a new cell, and then we will say DF1.
I got a bunch of things here. Is Hari near you? Messages. Okay, there we go.
Square bracket df1 square bracket, call out cr, greater than max cr. Run this, okay, and then come down. We'll say, so we want to, after we have done this, now we want to assign it.
Okay.
We want to assign the new data to a new data frame. So we say call the new data frame to be df2 equals df1 square bracket df1, okay, square bracket, and then cr less than max cr. You run this.
So I think what he did here is he created a new data frame. Okay, where the rows only included when the max when the CR is less than the max CR. Okay, that's what he's doing. So to a certain extent, it should be this right here, right? So I wonder who's still streaming on Twitch this. Nick Wan is streaming. what happened if we did a his plot? His plot. Wow, you talk about a distribution. Look how outside this whole thing up here, the rest of this is very evenly, very nicely distributed there in it, except for these outliers here. So, in actual fact, you could actually say, I think, is that is that these are outliers. These could be classified as outliers too. So let's just come back up here now. Hear that. Now we'll do a box plot also. But you see, now what you can see, these lines have extended out a lot more, but they're more into focus because we got rid of the 800 out here. But even some of these is probably too big. Okay, we could probably get rid of these last four here, but that's a decision for management. You know, so the question is, what's caused these outliers? What do we want to do with it?
So now to actually confirm that a change has been made, it is very good to always confirm the change. You say sns.boxplots open bracket df2 taking the square bracket cr. Now we run this. Let's see. Okay, so you can see that the data has actually been filled up. This is 250 and this is 300. Now we want to look at another column. We want to look at another column, which is we want to check another column. Let me see if let's take the HBAIC. Checking for outlier. HBAIC column. SNS.boxplots.
So you can see that the outliers aren't nearly as bad as HB1AC. Okay, I think is what he was looking at here.
Open bracket df2 square bracket, then you add it. Let me copy this HbA1c. Okay, I'll try and drop it here. Let's go. Okay, so we can see here that there are no outliers in this data. The distribution is quite even. So now let's check for the next cleaning, which is for duplicate values, the values that are duplicate. Now to check for the values that are duplicate, I'm going to use the method, I know this checking. For duplicate values. Now I'll say df2 square bracket df2 dot duplicated Okay, now when I use the dot duplicated method, it is going to give me either a true or a false statement. So depending on whether the column contains duplicate values.
So we do see a few truths here, don't we?
Values. So, but then if I use something like dot sum, what it will give me is the sum of duplicate values for each column. So I want to use the dot. I want to use the dot duplicated, and then when I run this, okay, so we can see here that in the first record we are having there is no duplicate value. In this second record, there is no duplicate value. In the third record, like that. Now, when we get to the record of 1000 or the 1002, we can see here that there is a duplicate value. Now, what do we do with duplicate value? The best thing to do with duplicate value is to drop it.
Oh, that's right, isn't there? There doesn't, if we come back over here, right? 1, 2, 3 duplicate values.
Yes, that is what we do with duplicate values. Values that are duplicated, you drop. So do df3 equals df2 dot drop underscore duplicates. Okay, and then we run this. Okay, so we can see here that it has.
Okay, let's do df dot drop duplicates. There's no, I guess the error is because there's no values for it to be there. So
Now let's confirm the change. To confirm the change, we'll say df3 dot duplicated open brackets dot sum. Okay, we can see here that there is 0 record that is duplicated. So that means our data set has actually been freed of duplicate values. Now the last thing I want to do is to save the new data. Saving the new data set into a CSV file. CSV means comma separated value. Now saving, we say df3 dot to underscore CSV, and then you pass in the file path. Now, since we are going to be saving the file into this data, the best thing we want to do is to just, into the folder, same as this Jupyter notebook. We'll just give it a name, cleaned data 2.csv, and then run. Okay, so our file has successfully run. So thank you very much for watching this video and actually learning one or two things. I await your comments.
Very good. Okay. Come back over here now. The last thing we do is we say the file outs. Wait. To CSV. Huh. I don't think that's right. Why wouldn't that work? This is kind of interested in it. Why isn't it working? Okay. That's kind of odd, isn't it? That's basically what we did over here. You know, Houston may have a problem here. Oh boy. What's going wrong up here? That's just what happened. Is that I'm thinking what happened is that the one function didn't work correctly, and so basically deleted the data frame, I guess. Okay. And that, dear friends, winds up the first hour or so on our stream this evening. 10, 12, well, you know what? Let's take a break and think about it. Back in 15 minutes or so, what's next on our hit parade. Okay.
ceremony held on the beach, Utah Beach, France,
Yes.
in 1945. So 1 year after the invasion at Utah Beach.
Okay, so as Eric said, we're standing right here at the very spot where that photo was taken in 1945. And he mentioned that one of the things that really stands out in this photo are the flower girls. Well, we happen to have one of the flower girls right here with us. This is Danny, and she is the girl right here in this American dress.
Bonjour, je m'appelle Danny Patrix. Hello, my name is Danny Patrix. En 1945, j'ai eu le privilège d'assister au premier anniversaire du débarquement.
So in 1945, it was a pleasure for me and an honor to have and to be there for the first anniversary of the D-Day.
Et pour cette occasion, ma maman m'avait confectionné une petite robe.
And for this event, very big event, my mother made a dress. Looks like American flag.
Hey, Georgia. Yeah, I am actually still alive. I'm also still streaming. Sorry. Yeah, thanks for stopping by, friend. I just finished up doing some Python programming. And earlier to that, you go back and watch the stream after it's finished. You'll see I also did a little. I used the chat GPT bot to create a Fortran program. It calculates what's called the Cortez number or number series. Okay. My question now: are you still there? Sorry, I didn't see you come in. What I was thinking about talking about tonight for the second part of the show is talk about how to use ODBC drivers to connect various databases that are not supported directly into things like Power BI and Excel. In particular, I'm going to take a look at the probably easiest database to use, which is SQLite. Okay. First of all, let's just go over and check something. I don't know if you've seen this chat. OpenAI.com/chat site yet, but that's that agent that's all hot now. It's you can use it to create write code for you, write write all kinds of stuff. Let's try something fun. Let's come back over this chat session. The question is how do you write a Fortran program? How do you write the output from a Fortran program to how do you read a Fortran program from a tape? Okay. Oh, this is pretty cool. See what we're doing now. I mean, how many people still read a tape drive in Fortran, much less out of language? But let's see something here. I need to come up with some way on. I'm streaming using Prism. I need to find somebody to come. So if someone comes into the chat, I get like a ding, a bell or something, you know. So the question is, how do we use to read from a tape drive? I realize you have no idea what I'm actually talking about. But back in the day, the first mass storage devices were tape drives, not hard drive. Okay. So enter your ISO status, tape drive, input unit for tape drive, real value, variable to hold the value read from tape drive. Tape drive equals 10, assign the tape drive as a unit 10, open. Anyway, let's see you answer that question. Now look at this. I just asked a random question about Prism software, and it's giving me an answer. Let's say, to add a bell sound that plays when someone enters the chat in Prism, you can use the add listener, event listener method uh, to the enter event, which is emitted when someone enters a chat. Okay, so where does this go? Okay, now where does this code actually go? Hmm. Hmm. Okay, what if we come over here to YouTube? Let's see. How to set up Twitch streaming on Prism. And let's see something here. What do we want to do here? Now this here, the V is kind of interesting. It's what it is. It gives you Vim or VI key bindings for your for your browser. So if I come from someplace, like I can say J. Now put it down here. You can see it goes down. If I do K, it goes back up. Go L. Okay, so that's kind of curious, isn't it? Anyway, the subject at hand now is how to work with uh, databases in, say, R or in Excel or Power BI that aren't not included with support. And the main reason may be that is because that particular database just isn't supported. Let's take a look at something here. See what databases are actually supported by Excel out of the box. Let's go ahead and take an empty file over here. So what we want to do, we want to use a database. But the question is, which database do we actually want to use? You can see SQL Server Access from analysis services, from SQL Server analysis services. Well, the trouble is, suppose you want to use another database, whether it's Oracle, whether it's MySQL, whether it's SQLite in our case, what are you going to do? Well, the answer is ODBC. All right. Now, if you're on if you're on a Windows, all you got to do is come down to the search bar and type ODBC. Okay. And you want to come over here, and over here you can see we got And the reason we're going to start with ODBC for SQLite is because that's the easiest one to work with, because it creates a single database file. There's no security with it. It's very fast, very small. It's really popular for the back end of like phone apps and stuff like that. Of course, freely available. So let's say we want to do that. So we saw and another reason to use it is because it becomes standard with Python. Okay. So we create a Python. We use our Python to read our data, to clean our data, to format our data, and then we upload it to a SQL Serverlite database. Now, in order to use SQL Serverlite, yeah, you have to install the ODBC driver. So as usually the case, ODBC driver C Lite. Then you search for the ODBC Lite, ODBC driver here. There's several places located, but I came to this one here. And you come down here and you download the driver to fix your system, and you install it. And that's probably the most complicated thing we're going to do here tonight. And then you say you want to add a new driver. Now this should work. You should be able to get a driver for PostgreSQL, for MySQL, for Oracle. There should be ODBC drivers out there for everything. Okay. So now you put a name here. Okay. And now this is the name of the database file you want to use. Now right here you can see we're using cyclistic bike share, but let's just look for a different one, just to make our point. Okay. So if we come down here, you can see we got our world database. Okay. Okay. And that's all you do. So now I go here, finish this. Now we come back over here, okay, to our data station. We come back over here to other sources, ODBC. And here's our databases so far: DSN, Big Data, our bike share, and now our most recent one is except I didn't spill our world quick, did I? Let me do this. Click Windows, connect. Amount of memory. This is interesting. Amount of memory. Huh. That's interesting. So that could be a warning there if ODBC uses a lot of memory. That could be a problem. Let's try Power BI then. Let's try it over here then. Old database, other services. Now, if you look over here for database, you can see server, access, Oracle, DB2, MySQL, Let's see. Is there an SQLite maybe? I just overlooked this. Okay, so yeah. So in our case, we don't actually have a, it does have a lot of the other ones here, okay? Google BigQuery, Access DB2, MySQL, very important one. Postgres is here, but what's missing is the SQLite. Other ODBC. Now this could be a problem if unable to connect, out of memory. Okay, so let's try a different file. Let's just connect to a smaller one. This should work fine, okay? Okay. And now this is all there is to it. Here's our here's two tables, okay, from both the this is another data set is like like 2 or 3 gigabytes big or something like that. Here's the original table. All you would have to say is come over here. No, obviously it isn't the fastest way to do it, but it does work. And it is interesting that Power BI has more database connectivity built into it than Excel does. Okay. Now this is interesting. C. Attempt to read or write protected memory. This is often an indication of that other memory is corrupt. Huh. Okay, that's interesting, isn't it? It actually does work, by the way. I can guarantee it actually does work. You know what the problem probably is? It could be that the prism could be using too much data, could be using too much space. Okay. So what would you do if this? Well, I don't know. If this happened on a job, I don't know what I'd do. uh, it's a memory issue. I mean, is it possible that there's that the, that the Prism software is just using too much memory? I don't know. Our world in data was too big. Obviously, use up too much memory. But originally got the problems with the our world in data, which was took up too much memory. Interesting enough. So obviously, this hasn't been the memory hasn't been released yet. Let's try it again. Big data. Let's try bike share. Okay. Now I see what happened. Now we got the two tables as part of this, okay? We try to do a transform. Now, that last time I tried to do a transform on these dates, things got a little crazy. Here's the problem right down here. Now, why is this happening here? So what's going to happen is when we convert this to a date field, okay, it's going to give us an error here. And then all we're going to do, we're going to say, remove the errors. Okay. Now this also, see the trouble, because SQLite doesn't have converted all these into date fields. We're going to try to see if we can do this, change type. Okay, so now this is a date field also, all right? So we'll come back over here. And we're just going to say, let's make a connection. We're going to try to get rid of any possible errors here. All right, now we're going to come back over here. Now we got this. So now we're going to come back over here. We want to create a data table. Insert. Back up here. Use existing connection. Ride counts. Pivot table report. Dates. And ride counts. Okay. Okay. Now we can come back over and create a report. And now we got our first report. All right. And that's basically how you use ODBC. Now, you'd have to use ODBC to connect to, say, a SQL Server database. You have to, for Excel, you're going to have to use more ODBC to connect to the other third-party databases, Postgres and MySQL. The difference is you will have to enter you will have to enter a username and password for your databases. With SQL Server 2019, you just use the Windows you use the Windows like I did earlier for SQLite. For say Postgres or MySQL, you're going to have to actually use your username and password for the database itself. Okay, but the process should be identical. All right. What we see here, of course, is very simple. We see sometime during the third quarter of 2020, the ride number just took a huge dive here, but they appeared to recover back in the first quarter of 2021. Okay? Well, Wimney Cheek, are you still there? I've been watching some of these Dark Corner reviews. He has kind of a sarcastic delivery. Occultist conjecture. That's the one I did earlier with. I did earlier. Okay. I used the chat GPT to create the Fortran code for this conjecture right here. Now this is interesting. The ultimate MS-DOS 7.1.
Courtney is deep in a practicum tech bootcamp, becoming a software engineer. She's wanting to.
Well, I'll tell you what. Again, Woodley Cheek, thanks so much for stopping by. I stream Monday through Friday, 8 p.m. Eastern Time. That's New York time for you folks out of the U.S. So if you get a chance, be sure to stop back by later on in the week, and we'll have a nice chat. Okay.